All right. Hello, everybody, and happy Friday. So today I was planning that we'll look on the transit routing in OCI and how we're gonna build that. So for that transit routing, usually you need it if you are gonna route the traffic, for example, from your on-premises network to OCI, and you want to use multiple VCNs. And one of the VCNs will act as a hub, and the rest of the VCNs will be as spokes. Okay, so this is what I was planning on building today. And on the left side we have OCI, where we have a hub VCN, and there we have one subnet where we'll have one compute instance. Then we have first spoke VCN here, and then another spoke VCN here. And let's see how long it takes. Maybe we'll just build one spoke, or if we have time, then we'll build the two spokes. So yesterday I was planning how to do this, and then suddenly I figured I'm missing the on-premises network. So what I did is I will set up a AWS VPC with the subnet, and then I have a VPN, IPsec VPN connection between the AWS VPC and OCI VCN, and that's already built and working. And actually, if you want to try it, there's a really good instructions from Richard in this post on ocblog.com, and it's connecting OCI and AWS with native VPN services. So I was just following that and connecting the VPC and VCN between each other. So now I have like the AWS acts as my on-premises network in this case. So let's look back on the diagram. So I already have this hub VCN, and then we are just gonna build the spokes today, and then all the local peering gateways which connect the VCNs together, and then we need to modify the route tables accordingly. So let's get started. Just gonna put the and I'm basically logged here in my own tenancy already, and you can see that I have the new dashboard here available. So that's, I think it was released this week, not too long ago. So on the, like, usually you land on this get started page, but hopefully like in the future you can switch this to this dashboard automatically or by default. And then you can just see all the stuff what you have built. So let's start with the networking. Taking a while to load. Okay, I'm just gonna go on my build compartment where I have already the hub is built. Oh, and one thing just to show like what we are gonna build is you see the cider blocks for the VCNs. So usually in the examples you have, for example, you can't have overlapping cider blocks here in the spokes and hub, and sometimes they use like totally different cider blocks. For example, 10.000 here and then 192 here. But I feel like the usual case is if you implement this, then you're gonna have like cider blocks which will be close to each other. So that's why I have like 10.000 here and 10.01 here and 10.02 here. All right. And just to demonstrate, I already have the, let's take the connection here. So I'm just gonna show that this is the AWS instance, and just gonna show that I can connect to my OCI instance. So here you can see that I'm able to connect to the hub instance. Okay, so it's set up. Let's go back. Oops. Building. So let's start building the hub. Sorry, the spoke hub we already have. So I'm just gonna enter the cider blocks. So now I'm just gonna use last 24 here. And if you have any questions, just put them in the chat and we can look them from there as well. So I'm gonna put this last 24 here. So it's gonna be quite small. And then we are gonna create the subnet. And this is actually like next time I'll be talking about the private DNS. So you can see the DNS resolver here, which you can modify, and we can look at next time. It's I'm at least excited on it. So let's create the subnet. Oops. So this will be our subnet private spoke 1, and let's use the same cider block. I'm just gonna use the default root table. It's gonna be private. Okay, gonna use all the default security lists. So just so we know that it's gonna allow all the SSH traffic here. So from the testing perspective, it will be a little bit easier. All right, let's create the subnet. And now, since it's gonna be private, I'm just gonna create like the NAT gateway and service gateway, just so that it will have like connectivity and outside if needed. So NAT gateway. Then we are gonna create the service gateway. And let's select all the services. Sometimes, like if you don't create the service gateway, I've noticed that the compute instance might not spin up, like if they can't access the Oracle services. So, all right. So we have the service gateway, and then we have the NAT gateway. So let's associate those with the default route table. And this is already something we did last time in the last stream. So we are gonna select the NAT gateway, and since that's gonna handle the, let's say, the internet traffic, I'll just use it, put all the 000 here, select my NAT gateway, gonna add it here. Then we are gonna add the service gateway destination. And it's funny, like in the service gateway, you can define like, is it the object storage service or all the services, and you can define it here as well. So basically in two places. Okay, gonna add that in the route rules as well. All right, so that's done. And next, actually, what we need to do is we need to connect the VCNs together with the local peering gateway. So let's create a LPG here. And I usually like to name these like spoke to hub. So I wish these would disappear automatically after some time. Okay, so now I have a spoke to hub local peering gateway. So you can see it's not connected to a peer because we haven't connected it. So now we're gonna jump back on the hub VCN. We're gonna create the LPG here. And we can name this as LPG hub to spoke 1, like this. All right, and now we can just peer them so they are connected. So we're gonna establish the peering connection details, or enter. So we select the spoke 1 here, and we're gonna select the gateway and just gonna establish. And you could basically do this with the different tenancies as well, so you don't need to be on the same tenancy. And I think that's something that might come up later on, because you've seen the latest announcements with the connecting the tenancies together with the billing, for example. So I think you might see more of those cases where customers are using multiple tenancies. Okay, so now these are paired, but what we still need to do is we need to route the traffic. So the routing, it's gonna be something that you usually end up looking like what's the problem and why you can't connect. But I think looking the the OCI documentation, I think they have a really good examples here. So if you are just doing the routing, you have these examples here that what you need to do in the route table, which is associated with this hub subnet, and what you need to do with the route table associated with this spoke subnet. But then also these two here, which is quite common that these are missed. So there's a route table what needs to be associated with the DRG, and then a route table which needs to be associated with the local peering gateway. So a little bit different things what are needed, so in order for it to work. Okay. So now I have the peering. I'm gonna go back to the spoke. Excuse me. Let's go back on the spoke. And now I'll just go on the route table, just using the default one here. I'm just gonna add route rules. So here I'm gonna add actually 2 route rules towards the local peering gateway. So the first one is to do the hub cider block, and we're just gonna select the LPG what we have here. You're gonna add it here. And the second one will be, we're gonna route the traffic to our on-premises network, which is basically the AWS. So we are gonna route it to also through the LPG. So any traffic what leaves from this spoke and is destined to the 192 address, then it's gonna be routed to the LPG and not to the NAT gateway or the service gateway. Remember that the most specific addresses always takes priority. And just gonna assign it here. Add it. Okay, so now in theory our traffic from the spoke should go towards the hub. Okay, but there's those couple of different routes. We still need to route tables what we need to create in hub so that it works. So let's take a look on the route tables. So I've already created these 2 route tables. So I have a route table DRG, which will get assigned to the LPG, and then the route table LPG, which will get assigned to the DRG. So if we take a look on the again on the this picture, we can see that on the DRG we need to route the destination traffic to LPG, and then from the LPG to DRG. All right, I think that's confusing enough, so we're gonna try to do it. So here on the DRG, we're gonna add the route rules. And this one is gonna have the local peering gateway, and it's gonna have this spoke side block here. All right, and we're just having one spoke here. All right, we're gonna add the route rules here, and this one will get associated with the DRG. Hopefully I didn't say it the other way around. Just let's go back. And now on the LPG, we are gonna add the rule towards DRG, and this one needs to be your on-premises side block, which in our case is the AWS side block. Yeah, and automatically, obviously, you only have one DRG in your VCN, so it's gonna be pointing to that. You don't need to select. Oops. What did I do wrong? Dynamic. Let's see. Rules in route table must use a local peering gateway, service gateway, or private, or route table can be empty. Okay, let's go back. So this is the LPG. Let's see. Let's first assign this one in our DRG. Okay. No, sorry. Let's take a look. Local peering gateway. Okay. So this one should be added on the yes, on the DRG. Yeah. So let's go back. And usually I go here and then here, DRGs. And I think now it needs to be this one. That was wrong. Now the DRG has the local peering gateway. And if we look on the example, yeah, same here. So that's why when the traffic comes from on-premises, then it hits the DRG, and DRG knows that the target should be the LPG. Okay. Now we need the other one, the other route table associated with the LPG or the DRG. Yeah. So we go here. We have this one. We're gonna add some route rules. DRG. Okay, let's try again. Yeah, now it went. Yeah, I think I was, because of I had the route table, wrong route table already associated there. Then it gave me this issue. Maybe the naming could be a little bit better with this, so I wouldn't get so confused. Okay, and this one we need to associate with the LPG. So let's go back here. Go on the, and you can see that the route table here is empty. So we're just gonna associate the LPG one here. And let's take a, yeah, looks correct. Okay. So now we've created all the route tables. So if we take a look on the route tables, we have the default route table, and actually let's take a look on that. So we need to add one more rule here. So we have the route going back to the DRG from hub as well. So that's why we can connect from the OCI hub to AWS. we want to still add this rule here, so that the traffic from hub, like if we are gonna connect from hub, then we can connect to this spoke. We go, just select this one, gonna add it here. now the rule should be there, and let's spin up a compute instance in the spoke, and then we can see how the connectivity works. Just gonna go here, copy my private key. Yeah, I have the always free instance running here in the hub, which is a public subnet. So let's create one more instance here. This will be our compute spoke 1 instance. I'm just gonna change the shape, so you can have two free instances running, which is quite neat. We're gonna select the shape, and we're gonna use existing network, private. Okay, looks good. Do not assign. We're gonna paste our public key so we can connect, and then I'm just gonna create it. Okay, so now it's already provisioning. I think it should take like a minute if there's no issues. So it's gonna have the 1.2, and I kind of like it. So it's predictable. So usually if you let the subnet, or you let the DHCP to assign the IP address, then usually the first instance will be .2, because also Oracle reserves the first two IPs there. So you know that it's gonna be like this. So that's why I predicted that in my diagram as well, even though I'm not specifying it. And you can always check the work requests here if there's something which is hanging and why it's not being created. So you can see the progress here, but should be done fairly quickly. And we can take meanwhile, we'll just double check that the security lists allow the traffic also from in spoke, because that's something that might hit you as well, that you don't have the connectivity. Then you start looking and, oh, maybe I had my own security list assigned or network security group, and it didn't allow the traffic. So you can see it allows all the traffic from, actually all the traffic from SSH traffic from everywhere, but we can just add, for example, all the traffic from our spoke, because this is a test, so we don't. Let's just allow all the traffic also from our on premises as well. But normally don't go and just add this. Like if you are dealing with the production VCNs, then there's usually a lot of dealing with the security lists and network security groups. All right, let's take a look on the instance. Is it running already? No, it's still provisioning. I've had this problem like couple of times, that it takes a while, and then I don't know why. I've had to terminate the instance and then try it again, and then the other one comes up really quickly. Maybe it's because I'm using like 2 free instances. So let's give it like 30 seconds, and then if it still doesn't work, I'm just gonna try to provision a different instance rather than a free instance. We can check in the meantime. Let's take a look here. So we can connect to our hub here, but let's try on the, yeah, it's not answering yet. Actually, we can try it from here as well. So this is our hub compute instance. Let's see. Yeah, it's not coming up. But it's okay. Let's just take a look on the networking. Like maybe I'm missing something in the spoke and subnet, and then I'll take a look on the actually on the route table. So if there's, so we have the NAT gateway, that's fine, and then we have the service gateway. So I think we should have everything what is needed so that the compute instance spins up. So let's still take one look, and I'm still provisioning, but it's fine. Let's leave it there. Let's create another one. It's gonna be our second. Use the same image. Let's just use this flex one. And yeah, spoke, private spoke. No, and let's just paste our key again. Let me just get it right here. Copy, paste it. All right, let's create it. Let's see what happens now. I'm just gonna terminate this one. And this is actually like it's still like I had to deal with the AWS console yesterday. I hadn't done it for a while, so I've been using OCI mostly lately, and I feel like the OCI, like the user interface, it's way better compared to AWS. But the AWS one where you have the instances, it's way more informative. So you see the, for example, the private IP, and that's something you usually need it, or would be nice to see it from this view. What's the private IP? I don't want to go click here and then start figuring it out. Okay, let's just terminate this our spoke instance. Maybe there was something. See, now it's running this one already. So I don't know. Maybe it's because of the service limits or something. Usually I can spin up 2, but I don't know. It should give you some kind of hint what's the problem. So now our IP will be this 10.0.1.3. Okay. So let's go back here. We are on the hub. Oops. Yeah, this. Let's go on the. Yeah, I had it here. I was testing something earlier. Now we can try it again. Okay, so we can connect from hub to our spoke. So we know that works. Okay. But let's see from the AWS instance. So we know we could connect to the hub already earlier, but we are just gonna try to connect to the, oh, same problem. No, I deleted both. Okay, doesn't matter. Yeah. Oops. Wrong key. Yeah, this was on the wrong directory. Okay, yeah. So now I can connect from my on-premises AWS to this spoke instance. And what about can we connect from the spoke to my AWS instance? So let's actually try it. So just gonna create the private key. Oh, just paste it here. It's the AWS. Just gonna get it here. All right, it's copied here. And don't worry, I'm just gonna delete those keys after this example. So like this, and now we can just try to connect. I'll get the AWS IP, and I was testing this like some time ago, connecting not here, not in this example, but I was gonna connecting to the AWS instance first time in a while, and I kept wondering why the connection is not working, but I was using the OPC user instead of the EC2 user. So that obviously. Okay. And see, I'm able to connect now to the also to the AWS instance. So yeah, I think for now that's it, like what we did. So we have the connectivity between the hub and AWS, and then we have the connectivity between the spoke. So we can connect from AWS, which would be our on-premises, to spoke, and then from spoke we can actually connect to AWS. And usually obviously you don't allow like connectivity to all of your on-premises, but you have some kind of firewall rules here, maybe on the OCI side, and obviously you will have some firewall rules on your on-premises side as well. So that's something that can't be usually worked by you yourself completely, because there's always somebody who controls the on-premises. So it's a little bit back and forth discussion to get everything working. But from OCI side, I think the biggest things that needs to be remembered are those. Let me just put the picture here back. So the biggest things are the so the route tables. So just as a reminder, in the hub VCN, you need to edit the subnet route table with the DRG and LPG, and then you need to have a route table for the DRG attachment, and you need to have a route table for the local peering gateway. So 3 route tables what you need to edit. And actually one thing still, let's take a look on the on the subnet route table in the hub. So it's the default one, and in these examples I'm just usually using the default one just for the clarity's sake, but maybe in real life you want to have a route table per subnet always. So you can see here there's also the route towards the DRG in the hub subnet, and then since this is a public subnet, then I have the internet gateway and also the service gateways here for the object storage, because if you have the internet gateway, then you can't route traffic to all of the services in that region. And yeah, finally the local peering gateway. But yeah, that's pretty much it what I wanted to talk about today. And I think this is the I wanted to have this stream or session first before jumping into the private DNS. So next time I'm gonna talk about a little bit on this same concept. So I'm gonna have this hub and spoke and the second spoke pre-built, and then we are gonna look how the DNS works with the new private DNS. How can we resolve addresses if we are here in hub and we want to, for example, use the spoke VCN? And what about here from spoke, how we can resolve addresses from here? Or even, let's say, if we can put the AWS in the mix as well. So I'm just gonna need to do some research with that first. But I think the private DNS, it's definitely something that will help everyone in the long term, even though like I wouldn't say it's limited, but there's only some features what you can use for now, and hopefully Oracle will bring some new features as well shortly. So then it's gonna be really nice. But in the initial testing, I'm really happy with the private DNS as well. Okay, but yeah, that's pretty much it. Thanks for watching, and hopefully you'll join again next time. Have a great weekend.